Hello guys, unfortunately I just recorded a video how to solve a string for a valid palindrome by removing only the alphanumeric characters and changing it to a lower case. So first we applied a filter condition to change the string to a lowercase string by also filtering out certain characters that we did not want. And then the filtered string needs to be checked for if it is a palindrome or no. So what I'm going to do is now, instead of rewriting the code, I'm just going to walk you through the code quickly. The first step of implementation that we started with was our filter function, which accepts the string. It changes the string to a lower case. Then we try to filter out the characters to only keep alphanumeric characters. We researched the ascii table to find out that the lowercase alphabets are in the range of 97 till 122, and the numeric characters are in the range 48 till 57. So that's why we have these two conditions. We created a new function called isInRange. This function takes in the value of the ascii character as a number and checks if it is in the range that we provided to. So if the given character of a string that has been forced to be a lowercase is falling in range of a lowercase alphabet, or it is falling in range of the digits 0 to 9 on your keyboard, then we filter this character and mark it as true, and we accept the characters in our filtered string. So this is the logic of our filter string with conditions function, which is then we call this function get a filtered string. Now the one of the ways to check if a string is a palindrome is we take a string in memory, we reverse the string in memory, and then we compare the original string with the reverse string, and if it reads the same, then it is a palindrome. A memory efficient way of checking if a string is a palindrome is to set up pointers. So we set a pointer, one pointing to the left and one pointing to the rightmost character of the string, and then we simply keep checking that if the current pointer location is the same as the current right pointer location, current left pointer location is the same as current right pointer location. If at any point we find that the characters at these two pointers are not the same, we return a false. Then we increment the pointer to the next character, so left comes to m, right comes to m here, so on and so forth until left is crossing right, because if left is equal to right, it's going to be the same character. So if it's a string with odd characters, the middle character is allowed to be by itself, and as soon as left is equal to right over here after these operations, we stop and we return a true. That is, all the characters on the left side are equal to the same corresponding characters on the right side. Now let's take this example. The left is at R, right is at R. It passes left is at A, right is at A. It passes left is at C, right is at C. It passes left is at E, right is at A. It fails. So for all test cases over here, when we run this output, we get the response that we are looking for. When we try to submit this code, I already tried submitting the code twice. I also had one optimization done. Unfortunately, the entire video did not record. As you can also see, I have a tab open that says how to recover deleted or unsaved QuickTime recording. So yes, this was our submission, and yeah, it is slower this time with the actual exact same code, but I think it is because of LeetCode's efficiency over here, and the code is as efficient as I can think it to be. So yeah, ciao, have a nice day. This was a quick session.